Good morning. I'm Eve Farrell. I'm a senior biology major here at Carleton College, and today's convocation speaker is David Gallo, an esteemed oceanographer and pioneer in ocean exploration. Throughout the course of his career, Dr. Gallo has participated in the development of scientific technologies and discoveries that push the bounds of how we view planet Earth. Dr. Gallo received his bachelor's and master's degrees in geology from the State University of New York at Albany, and received his PhD in oceanography from the University of Rhode Island. For nearly 30 years, Dr. Gallo was the director of special projects at the Woods Hole Oceanographic Institution, an esteemed, globally recognized scientific laboratory. He participated in marine expeditions of every ocean in the world, and was one of the first researchers to utilize the combined capabilities of robots and submarines to explore the deep seafloor. Dr. Gallo recently co-led an expedition to generate the first comprehensive map of the RMS Titanic. He has also co-led successful expeditions to locate the wreck site of Air France Flight 447, and is involved in a series of expeditions to the Mediterranean to locate the remains of Ernest Shackleton's ship, the Endeavour. Dr. Gallo is an advocate for the development of new technologies for ocean exploration. He is a member of James Cameron's Deep Ocean Task Force and the X Prize Ocean Advisory Board. He is also a proud member of the United States Nifty 50 Scientists and Engineers. Among many other accolades, Dr. Gallo is a co-recipient of the Computer World Smithsonian Award and is an elected fellow of the American Association for the Advancement of Science. His 2007 TED Talk, Underwater Astonishments, has over 14 million views and is one of the most popular TED Talks of all time. Outspoken about the relationship between humanity and the sea, Dr. Gallo believes that the oceans hold the clues to our past and the key to our future. Please welcome Dr. David Gallo to Carleton College.
Thank you very much. Thank you. Thank you for that introduction, and it's a pleasure to be here. I've been to this part of the world maybe 5 times. I'm always stunned with how beautiful it is. I've never been here in the fall, and I just went through New England on a jaunt through the fall leaves, and they've got nothing on Minnesota. I mean, it's even in the drizzle, just positively stunning. You know, it's odd. I get asked a lot about my favorite place on Earth, and I always say, in my hammock in my backyard, and then the person will say, "No, really," and I say, "No, really." And we just had that winter storm. Actually, it's not a winter storm, a northeaster, that still people 3 days later are without power, and nature decided to drop a tree on my hammock. So I think there's a signal there for me to pay attention to. I have ADD, as you'll notice. Sometimes I say I'm the ADD PhD, and it's a nightmare to be on Keynote or PowerPoint because it's like a railroad track that I have to stay on. But I want to introduce you to some of the things that I've been fortunate enough to be involved in. You know, to begin with, I show this slide. And I don't know that you can define exploration for an individual or discovery of the thrill. You know, it's an emotional thing to me, and everyone looks at it different ways. For instance, the Grand Canyon. You may have never been to the Grand Canyon and just be positively amazed with the grandeur and all that. In effect, you're exploring something new, even though so many people have been there before. So I don't know that I like those kinds of terms. That's our planet, and the thing about this is that most people take this for granted, the big blue marble. And also they don't realize how much effort went into bringing that picture back to civilization, to us here on Earth. The mistake there, or the challenge there, is it makes us think that we really understand this planet, and we don't. That's a still image, it's a snapshot, and really the planet is incredibly dynamic. So everything's changing. The continents are changing slowly. The oceans change as well, a bit quicker, much quicker. And then the atmospheres, all those clouds are constantly moving around. So you don't get that from a still picture like that. For instance, that's the world spun around. It took the clouds away from Earth, and that's the Pacific Ocean. And the Earth is covered 70%, as some of you know, by ocean. Average depth's about 2 miles. So it's a water planet. In a way, it should be called planet water, planet ocean. And this slide always amazes me because you can just see a little bit of North America in the upper right. That's California. You can see Baja, California. And it's New Zealand way down in the lower left. Now, that's the way most people think about the ocean. And that's the way I thought about the ocean. I grew up in the middle of New York State, central New York on the Finger Lakes. So I watched Jacques Cousteau. I knew there were French guys in Speedos out there doing exploring. But I didn't think much about the deep ocean. Like as I said, it's about 2 miles, 2.5 miles is average depth. So that's a very important part of the ocean, the beach. It's where humanity and the ocean really come together, but it gives you the wrong intention. The other thing was that as a child in elementary school and high school, I was launching rockets and I was in the backyard with my telescope every single night. And I was a little bit disappointed that when my first meeting with guidance counselors, they said, what do you want to be? I said, I want to be a scientist. And they said, well, maybe you should think about something else. And this is the proof. So that's just one grade. You can see at the very end, my stellar performance. And it comes back to ADD. All these are, I remember in the lower right, the 76, 71, and the F. It's been erased and written over. I remember my mother saying, what's going on? What did you do here? I said, Mom, if I did it, I wouldn't give myself a 71 and an F there. So here I was president of the Math and Science Club, president of the Astronomy Club, and yet, because of my grades, told, you just do something else with your life. And I did. After I tried community college after high school, and it was horrible. I was bored. Same thing. I didn't understand what taking notes was all about. So I sold shoes for 7 years. And I loved it. It was great. I would stand behind a counter just like this podium at night and greet people all day long and all, during the evening hours. And one day I was looking at that very image, that very magazine, 1976. I was 24 and was thumbing through it at the counter, and I came across that image on the right, which stopped me in my tracks. And it's an image of an underwater mountain, and you see that little tiny yellow circle, and then the blow up that circle is the submarine Elvin with 3 people inside it exploring this underwater world that I never knew existed. Mountains, strange animals, volcanic eruptions. And this was Dr. Robert Ballard wrote this article. So I didn't get smarter. I just got driven. My curiosity was ignited again about the world and focused. And I was determined that that's what I wanted to do. And it was 2 years. I went from that to getting my bachelor's degree, and then making my first dive in that very submarine, and publishing my first paper and it wasn't just me. I had a big support group around me, and again, had nothing to do with being smarter. It had to do a lot with being focused and coping with ADD, finding a way to work with it. That's from my thesis. It's just mapping the deep sea floor, and that orange line down the middle is a volcanic axis. I just wanted to show that's what I did that to. And every night in those days when we turned on the equipment, the sonar, we would find new mountain ranges. The oceans have never been mapped before. And today, several decades later, we've only explored about 6 or 7% of the deep sea. Have no idea what's there. So basically, we're living on an unknown planet. Oh, my ADD. So I was in Borneo, and I was curious again about these crocodiles. And I was in a small boat with basically a guy paddling, and I asked him if we could get a little bit closer. He really didn't speak English. I really didn't speak Malaysian. And we got closer, all right. I took that with my iPhone. It was almost the last picture I ever took in my life. But I keep looking at this thing. What in the world? What was I thinking? And it didn't always. He was fixed like that with jaw open. So I thought maybe it's not really a real crocodile. It was a real crocodile. Okay. So I showed you the Earth with water. Now I stripped away the water and the seafloor. It's got the world's largest mountain range, greatest mountain range, the mid-ocean ridge. I'll show you a better picture of that in a moment. It's got thousands of peaks that are higher than the Alps along it. It's 50,000 miles long, 70,000 kilometers. It's all one big volcanic axis, and there you see it down the middle of the Atlantic and between Australia and South America. It's cut by thousands of valleys that are many times wider and deeper than the Grand Canyons. So underwater mountains, underwater valleys. We have underwater waterfalls, well, actually underwater rivers. At the surface, we call them currents, and the same thing. We have currents that move along the bottom of the ocean across the seabed, and they actually do carve, you see how a river carves through the land on the surface, same thing at the bottom of the sea. And sometimes those rivers go over the top of some of that steep topography I told you about. So the world's largest waterfall is between Iceland and Greenland. It's called the Denmark Straits. And it's many times, everything's many times what we have on land, but it's many times the Amazon, the flow of water. And as I said, the deepest waterfall on the planet happens to be beneath the sea. Oh, underwater lakes, I forgot the lakes. Almost everything we have up here under the sun, we had find at the bottom of the ocean. Most of it never predicted, almost all of it, because someone stumbled across it. I'm sorry, I had back surgery this summer, and my doctor's trying different things so my muscles don't spasm. This is great, except I can't talk. I was wondering if my wife had something to do. Okay, that's a close-up. That's the Atlantic Ocean. And it just shows that mountain range a little bit better. And it also shows the shape of that ridge mimics the shape of the continents on either side of it because they're related. It was part of plate tectonics. And I'm showing you this just because, A, it shows the Earth always changing. You know, mountains come and go, oceans come and go. Everything's always changing. And how well it works. You know, it really does work. Part A goes into part B, and they once were together. And the most important thing probably is that it has not stopped. Plate tectonics continues today. We have it in our notion, this notion that plate tectonics, what we have today will be tomorrow. Same thing true with climate. And I'm not saying humans, we play an ugly role with climate change, but climate's been changing for billions of years, and it's not going to stop. Tomorrow will not be like today. It's going to change. Oh, gee, there we go. Okay, so that underwater mountain range and technology. Exploring the deep sea means you have to have very specialized technology. And probably the most romantic and dramatic way to explore is a submarine. So in that submarine in the foreground, there's a titanium sphere. In that sphere, there are 3 people, a pilot and 2 scientists that the pilot keeps separated because of their, you never want two scientists that close together in a sphere, which always causes trouble. Always causes trouble. I want to go there, no, I want to go here. And the pilot is the one that decides who goes where. Those 2 people on the outside are called swimmers. They make sure all the gear is in place, that everything is safe, and then they hop off in the water and they give you the okay to dive. You add a little bit of water to the submarine and down you go. In the meantime, on that surface ship in the background, there are 50 people, so you've got a whole support crew. And it's a mix. About half of that crew is the ship's crew, and they're there to run the ship. That's their home, that's their job. By and large, they keep you alive. This is a scientific crew. There's technicians, there's engineers, there's every kind of carpenters, everything you can think about, because quite often we're thousands of miles away from any place, and you need, if you need, something breaks, that's where you go through. So yeah, the focus is on the sub, but it's an entire team of support in the background. Everything in the oceans, especially the deep ocean, requires a team. That's on the right side, the inside of the Elven sphere, and now normally there would be 2 people there, and on the left, just to compare, the Apollo capsule. And in both cases, it looks like there's a lot of space, and I can tell you, in the Elven sphere, there's not a lot of space at all. You can barely stand up, you have to crouch, and pretty much you're on top of one another. My advisor is 6'6", and so, and he would sit on the left side of the sub, and then he'd drape his feet, his legs, over some of the equipment onto me. So it's always, luckily you get so focused on what's happening outside that you don't think about the discomfort inside. And you know, it's an incredible journey. At the surface, you have the wonderful blue. You can hear fish, whales, dolphins, and you float down through that, and the light gets less and less. The blue gets deeper and deeper. And you get to this world called the Twilight Zone, where you can barely see anything out there in the ocean. And then into the deep, after about a half an hour, pitch black, freezing cold, and for the next 2 hours, it takes 2.5 hours to get to the bottom. So for 2 hours, you're in this world of cold and perpetual darkness, where we were sure nothing could live. That's submarine diving, and like as I said, eventually it fades away into that darkness. I'm going to play some music background to this, but some of the animals that we see in this world where we said there should be no life at all. The jellies, fascinating. Even in the Marianas Trench, 7 miles deep, we find jellies. And many of them, almost all of them, in fact, have bioluminescence. The vents on the top of that mountain range, the temperature of that water coming out is 750 degrees Fahrenheit. Toxic, full of hydrogen sulfide, and yet it supports an incredible ecosystem of life. In one spot, 300 species of life, about 290 of those species brand new. The life here lives on microbes that actually live around that hydrogen sulfide, so that's their lifeblood. An image we've never thought we'd have would be looking down. That's a robot at the bottom of the ocean. The cameras, it's not just the submarine, not just the robots that we use, but it's the cameras and sensors have gotten much better too. Most of the ocean, well, about a third of it is the abyssal plains, where not a lot goes on. It's a sort of bleak world. And then here we go. Actually, right now, the sub is going over a shoreline. This is one of those underwater lakes. This is actually a small pool. But you can see on the upper left, you'll see that there's another shoreline. You'll see it in a moment better. There we go. So right below the sub right now, there's underwater. It's water. It's another body of water, and it's even got waves in it. There's animals that live all around that water. There's animals that live inside the water. The animals in the sea don't go into there. So it's very strange, and again, not predicted. But you know, initially, we were told nothing can live in there because too salty, too full of methane and the like. And we said that's true, except all the life we see in there. You know, I forgot to turn my timer on. Can someone keep track of, okay. Can you give me a 10-minute warning? Great. Some of the other tools I want to show you are robots. This is autonomous. You launch it off the ship, off it goes, and it comes back. And sometimes we take 3, 4, or 5 of these out to sea with us. It's pretty amazing. So instead of the sub, which moves very slowly, you can launch one of these. Robot that launched to the bottom on a cable, so you drive it like a video game from the surface ship. It's nice, so instead of 3 people exploring, you can now have a whole team of people on the surface ship. You can, with a satellite, you can beam it back to land. You could drive a robot around the world from the other side of the world right from here. Just to show you the difference in the two kinds of data it brings back, on top is the Titanic, the bow, Titanic broke in two. Top image is made with sound. Sound goes a long way beneath the water, and we mapped a huge area around the Titanic. And then on the bottom is a mosaic made with cameras. So we're getting really good finally at being able to look at wider and wider areas of the seafloor. In the past, you could take, with a camera, you were kind of limited to how far light would go, which is not very far. I just want to show you quickly some of the video from Titanic. I came to Titanic, Bob Ballard, the guy that invited, started this whole thing with me in the sea, invited me to come to Woods Hole because he found Titanic. And I always kept it at arm's length. I mean, it was not one of the favorites of the scientific community. It was considered a little bit of showboating, too popular. But you know, it always takes, again, very specialized technology. This is very dangerous to be on a shipwreck in the submarine with tangled wires and everything on sharp edges sitting around you. That's the bridge, what's left of the bridge of Titanic. And so on that would have been the steering wheel and the telemotor saying forward, back, reverse, that kind of thing. The Titanic, we're not nearly done. It's got so many more stories to tell. And I never thought that. So I stayed away from Titanic. Then little by little by little, it started to get its tentacles into me. And it's a fascinating place to go. One from the personal aspect of the individuals that were on board, but also the ship itself, about what's happening to that ship. It's actually being eaten by bacteria at the bottom of the ocean. The seafloor around Titanic is littered with hundreds of thousands of objects, some of them personal objects, some of them from the ship. That's a piece of a bench. There's all sorts of dinnerware. There's beautiful pieces of art, bronzes and things. One of the big questions today is that that's in the deep sea, in the middle of nowhere, basically. Who owns it? Not only who owns it, who protects it? And you can go to any place on Earth and mention Titanic and people know what you're talking about. Always draws a crowd of people. So I love this image. It's a cup sitting on the bottom of the ocean in the dark. And you'll see in a moment, they've got the White Star line, it says on the bottom, and the White Star logo. Titanic has the wonderful addition to the spot of being, if hurricanes were on a railroad track, that track would go right through Titanic. And the last expedition I was on, this is a model. There was a hurricane brewing in the middle of the Southern Ocean, and 3 days later it was predicted to be there, which would be bad. And so the captain, which he worked very closely with the captain of the ship, and he said, I think we have to get out of here tomorrow noon. And that's okay, no one wants to be in a hurricane. And we were about 3 days from the nearest port in Newfoundland. And he came down to the lab shortly after that and said, we got to get out of here right now. We need to leave because the hurricane had picked up speed. The hurricane can go 30 some odd miles an hour. That boat would go 10 miles an hour. So we had to try to get into the port before the hurricane caught up with us. So I told the gang, I was co-expedition leader, let's get everything off the bottom and let's get out of here. So they started bringing things up from the bottom, transponders for navigation. There's no navigation, no GPS at the bottom of the ocean. It doesn't pass through the ocean, absorbs it in the very top. So recovering things takes about 3 hours to get everything on deck, bring up the robot, call back the autonomous vehicles. And I went back to my room to jot all this down in my log, and there was a knock on the door. It was my friend Billy, and he said, you better get back down to the lab, we have a problem. And I said, yeah, right. And he said, Dave, you better get back to the lab. And that's what I saw. Now, that's an animation of what was going on. And that's our robot with our tether attached. And the tether is firmly wrapped around a piece of the Titanic. So at that point, we had to leave or join the Titanic after the hurricane got to us. The choices were pull, on the cable, and hopefully that comes loose and comes up to the surface, and doesn't have a piece of the fear there was that you would bring a piece of Titanic back with you, and that's not a good thing. That's an ugly moment. Also, by pulling, you can break the fiber optic connection, and then you don't know what's going on. The other thing we could do is cut the cable, and that's leaving several $1 million worth of technology at the Titanic. What was amazing was on a ship full of the best and the brightest engineers and scientists and technicians, one guy that didn't say anything for most of the expedition said, you know, we ought to try doing this, drive that way with the ship and turn the robot that way. And I said, let's try it. And within about 10 seconds, the cable was loose and we were on our way. We didn't quite get into port with the hurricane. We got the edges of it, which was plenty unpleasant. That's about as happy as I get right there. That's the whole expedition leadership, so to speak, right after that incident. Not everything is wonderful in the deep sea, and this is part of my TED Talk, a very short bit of it. But you'll see here in a moment a pretty big octopus. This is in shallow water, about 30 feet, and there he is, right there. It's the work of Roger Hanlon, and he studies camouflage. And you see off the octopus went, and Roger could catch it pretty easily, but amazing how octopuses can do that, because it wasn't just changing color to match the background, it was also changing texture. So here's this large, smooth-skinned, light-colored creature on the right, and it's going to turn into that stuff on the left. And here he goes. And this is much slowed down, so it happens much faster. Amazing. And that's just the beginning of every time is something more amazing. I copied this from Nature with the blessing of PBS because it fascinates me. Another bit about an octopus. So in a moment, a cute little guy staring at the camera, wondering what it is. And then you'll see it's a bad place for an octopus to be because predators can get it. One thing they do is they walk on usually two legs, so it confuses any kind of predator about what that might be. And he's looking for shelter, and he looks off in the distance, and lo and behold, he sees a coconut shell. There he goes. There's half of a coconut shell, perfect. And he hops, puts his arms around it. Very odd, cumbersome, but there he goes with his coconut shell, because off in the distance he sees the other half of it. And there you go, there he goes. So now he's got two halves. He pulls them together. I still can't believe this happens, and it happens, every time. And this is several years old, a couple years old. Found even more amazing stuff. He peeks out the top, and he's really looking for predators or prey. And he sees some prey off in the distance, so he has to pick up his little hut and move again. I always feel bad for him. There's a flatfish flounder, and he's not interested in it. But there he goes, a crab, perfect, loop, back to his little hiding spot. And so that takes quite a bit of time to drag this thing around the ocean floor. So when he wants to move faster, he pulls both sides together and does the natural thing, which is to roll across the bottom. There he goes. Yeah, amazing, just amazing. I can't eat octopuses anymore, I just can't, I stopped. They're just too amazing, the creatures. Okay. Exploring the ocean, there's two parts of it. One is the excitement of discovery, and every day, every expedition, we find something new, and sometimes it's revolutionary. But that's the Earth from space. The other part is it's important to understand the ocean. Why? Because no matter where you live on the planet, the oceans impact your everyday life. And no matter where you live on the planet, you impact the ocean. What you put on the streets here, golf courses, backyards, farmlands, makes its way, ends up in the river, the Cannon River, and down to the sea. Eventually it goes. One of the things, so normally we're looking at small things, meaning a shipwreck, But we're also studying how the oceans move heat around. Climate change, the oceans play a huge role in climate change. And that's the Gulf Stream along the East Coast, and what it's doing is bringing heat from the lower left, Florida and the equator, the tropics up to the northeast in the ocean. And it's what keeps Ireland and England and Northern Europe green for the most part, so you can grow things there. If you come across the ocean at the same latitude, you end up in Newfoundland and Labrador. Same latitude, but not heated by the Gulf Stream, so barely anything grows there. And one of the worries today is that the Gulf Stream is breaking down, and I'll show you that in a moment. This is an animation again. Red is hot water, warm water heading north. You see how we simplify it with arrows, and that's the winds coming across that warm water. There's humidity above it, so the winds pick up the humidity, drop them on the continent. It's a wonderful little thing. And then the oceans, when they lose their heat, they become dense and heavy, sink back into the deep ocean. So you have to have that, we call them pumps, you have to have that ocean pump, water pump, to make this whole thing work. And part of what's going on today is because of climate change, there's a lot more rain and fresh water entering the Arctic region, the northern regions. And this is all salt water. Fresh water doesn't want to sink, so it's starting to encroach on that pump. There's the winds coming across, still carrying the humidity onto Ireland and England and all the like. But eventually, that's light blue is fresh water, and it starts to break down that whole system so that the winds now start to cut across water where there's no humidity. And we call this mini climate change, abrupt climate change. And it's happened in the past that Europe can go from what it is now to almost a deep freeze. And it can come on in 20 years, and the last time it lasted hundreds of years. So it's one thing that we're keeping our eye on right now, but you have to understand the ocean to understand what's going on. You can't, it's not an emotional thing. It's something that you have to have fact for. You have to have science to figure out what's really happening. So the oceans today still unexplored, but they give us the air we breathe. About every other breath of fresh air you take is from the ocean. Food we eat, the oceans give protein to about 2 billion plus people. They depend on the ocean. Water we drink, almost all of this comes from evaporation from the sea to the sky to rain. And yet we don't understand it. And from the other end of things, as I said, we have an impact on the ocean. If you go to the middle of the Pacific Ocean, catch a fish, look at the stomach contents, you'll see little bright bits of plastic inside there. If you look at the flesh, analyze the flesh, flame retardants, pesticides, all sorts of nutrients, pharmaceuticals are in the flesh. We're almost in a way eating our own garbage. Not everywhere, but just because they're in the middle of the ocean doesn't much matter. So it's a real difficult thing. We get focused on things like oil spills. Why? Because you have dead animals soaked in that black oil. It's an event. We have the ship offshore if it's a ship, that's up on the rocks. The media loves these things. But to say that things are trickling off our backyards and off our city streets, and it's clear water for the most part, media is not interested. And yet that issue is one of the most important things we need to understand is how do we stop this. Plastics we're working on. And it's not just plastic bottles that are the problem, it's really the breakdown of plastic into the chemistry that we have to, these we can pick up, but the chemistry is a bit different. So we're in a bit of a bind here with the oceans that we depend on it in a way depends on us, and yet we don't really. We have this intimate relationship, and yet we don't quite understand one another. One day we were trying to figure out how is it that on Earth there's billions of people without fresh water when we said it's the ocean planet covered 70% by water. And so we decided to show the volume of water against the Earth. And there we have taken all the water off Earth. That's that big ball on the left, not so big compared to the planet. That's all the water on the planet. Glaciers, groundwater, rivers, lakes, streams,
ocean water. That's it. And why is that it? Because I said that the depth of the ocean average was 2 miles. But oceans are 5,000 miles across in some places. So you have a layer of water that's 5,000 that way, but only 2 that way. You know, it's thinner than the skin on an apple. So that's all the water on the planet. The next ball to the right of that is water that's fresh water that is in our lakes and streams and whatnot. And that little tiny dot just beneath the ball on the right is fresh water that's available to us. That's all the water there is that goes in our lakes and streams, but for drinking water for this entire planet of 7 billion plus people heading to 9 billion. So it's not plentiful, it's not too big to fail, and we need to treat fresh water. It's a very precious thing that we have on this planet. So back to that again. When you see this image again, you just have to realize one more time that it's an unexplored planet. I keep telling that. I have some astronaut friends, I have some a lot of NASA friends, and I keep saying, stop looking for planets, unexplored planets with water. We have one right here that's unexplored, and we've got fresh water. I do love what they do. Finding the vent water, the creatures that live on the very deep ocean without sunlight. They're chemosynthetic, so they're taking poisonous fluid from the inside of the earth and turning it into, microbes do that, turning it into food for larger animals. That opens up a whole bunch of other places in our solar system where we probably have life at some one form or another, like the moon of Jupiter, Europa. It's got an icy cover, huge ocean, a lot more water on it than Earth, and it would be surprising if there wasn't life beneath that icy surface. What does the future hold? The only way that we're really going to get out of this predicament, and I don't like the word crisis so much because it's happening very slowly, and there's a lot of inertia. It's like turning a ship if you're going in the wrong direction, like the Titanic. You know, they saw the iceberg 30 seconds a minute before they turned it, before they tried to get out of the way, and it was too soon. So it takes a lot longer to move something like that. And I think in the case of climate and our treatment of the oceans, it's going to be the same thing. There's no quick fixes here. It's going to take leadership more than anything else, and understanding. Those leaders need to have the right information at their disposal. But I think this week is the big climate conference, COP26. And I think the amazing thing about that, to me, it's 26. This is the 26th, if it's 26, I think it is. This is the 26th time they've convened. Every year we have galas, black tie, at some of the greatest resorts and hotels, and we hand out medals to people for doing the best to keep the oceans preserved and conserved. And every year the ocean is in worse and worse shape. It makes me crazy that we have all these parties congratulating one another when things aren't really getting better, they're getting a little bit worse. I'm optimistic because for the first time we have a lot of information, so we know what's going on. Now we can't say, well, we never knew, because now we do know. So now the trick is to take action to that. I want to leave you with a quote by Marcel Proust. I'm not a Proust scholar, and there are many Proust scholars. I got this off a Hallmark greeting card, but I'm being honest. It says, the true voyage of discovery, not so much in seeking new landscapes, which is normally what we do, but in having new eyes. And in this case, the new eyes come through, among other things, new technology, new views of things by the younger generation of people in general. And the question is, with all this new stuff, the new eyes, is what do we do with that info? Do we just put it on the shelf and say that was nice, or do we actually take action? Thank you very much. I'll leave it at that. Thank you. Thank you.
All right, well, we have an opportunity to dive a little deeper. See what I did there? So if you have some questions, just raise your hand and I'll bring the microphone out to you. And we'll have some questions for Dr.
It can be anything,
Gallo.
sea monsters, pirates. Tight.
Yep, okay.
Are you a fan of Clive Cussler's novels?
You know what? I'm not, actually. And, well, I can't read. I mean, I can read, but because I have a nonverbal learning disability. So a book, I envy people that can read, sit down and read a book. My den is full of books. And with the new Zoom thing, people say, have you read all those books? Yeah, of course I have. No, I haven't. Once I was introduced, they really botched this up. It was a meeting of TV executives, and I was introduced as the real-life Brad Pitt instead of Dirk Pitt, who's in the novel. And Brad Pitt was just as, I'm not sure which was worse, being ever introduced as Dirk Pitt or Brad Pitt. They probably said, what? But no, the easy answer is no. I know of it, but I met him, just not, I have not really read those novels.
Where would you recommend that lay people like ourselves go to find information about the kind of complex discoveries that are being made with currents and atmospheric stuff? Where can we find out more?
That's one of the most dreaded questions that we get is where can I go to, or what should we do? To me, the best place is NOAA, the National Oceanographic and Atmospheric Administration. They've got a site on the oceans that will definitely point you to other places so you can follow your own curiosity. And it's fascinating, some of the things that's happening out there, that are happening out there today. So I think that's the best place. They have climate, they have exploration, weather systems, the whole works. NOAA, NOAA.org, I believe it. No, NOAA.gov, it is.
Hello, I got two questions. The
Yep.
first, per your urging to ask anything, I was wondering what your favorite shade of blue is.
You know, people just told me that my friend said, oh, you're wearing your, I forget what they called it. It's not royal blue, maybe sky blue. Yeah, I think it's got to be this. It's got to be that.
Awesome. And then my second more serious question is, how do you view the push to assign legal rights or environmental personhood to bodies of water as it relates to the ocean or underwater rivers?
Well, it's a great question. I mean, the same thing goes for the atmosphere. It's something we share with other countries, with other people, but there are no boundaries. So it's a real tough one, and again, it takes cooperation. There's a law of the sea, there's all sorts of things like that, but I spent a whole day just last week talking to a lawyer about that very issue, is how do you and she worked on the UN law of the sea stuff, about how do we do this and make it work, because if you don't sign it, a signatory, you're not bound to anything they say, and most countries haven't signed it. So it's pretty much the Wild West still. Yeah, I mean, shark finning, there's a lot of shark finning that still goes on, incredibly so. And, we say it's bad, there's whaling that still happens, people still collecting whales. I'm not sure what the total answer is, but.
What advice do you have for people with learning disabilities who want to go into the sciences?
That's a great thing. My curiosity made me focus, so having a focus certainly helped me because I had a goal in mind that was feeding my curiosity. I'm curious about everything. I could spend a whole day in my backyard and be fascinated, or spend a whole decade in my backyard. But I was focused on that's what I wanted to do. And so having that flag ahead of me, that's where I'm going. Then I had to find out, how do I get there? Okay, well then I need to find ways to cope. I worked harder, I took more notes, I rewrote my notes several times every day. I really practice and practice and practice. What I found was, and I think anyone with that issue finds that there's a certain power in having that too, if you can harness that, like hyper-focus, and I could do that. I could focus on something like no one else could focus, because I had to do that. But it turned out to be really helpful to me in my PhD. I have to tell you that when I went to Woods Hole, I remember they said, "Oh, you hired Gallo?" And so what are we going to do with him? And I said, "I know what, special projects." So he put me, which fit me perfectly.
Do you get seasick? And if you do you have any advice for people who may be going on ocean expeditions?
I've seen people seasick for a month, and it's horrible. I don't normally get seasick, and there too, I've had expeditions where literally you're kind of walking on the walls because the ship is doing this, and sometimes you bang your head on the ceiling because the ship's doing this for a month at a time. One of the worst things to do, I think, is to put patches on and take medicine. In Antarctica once, we had to evacuate a scientist, and it was not cheap because she was I was really concerned about her, but it wasn't just a seasickness, it was overdosing on various drugs that she took. Usually being outside and looking at the horizon helps a lot. And then trying to get into your mind, oh, I know what's going on. And you know, it's not always the slamming and banging that makes you seasick. Sometimes it's just tiny little movements where you're sitting there going, whoa, you know, something's not right. And that's usually, for me, that's one of the things that makes me feel a little bit queasy. I did from Titanic, a live program with Weather Channel. And so when the camera went on, it was pretty rough, and there were cords hanging behind me on the wall, and they were swinging back and forth. And the producer said, "Can't you stop those cords?" It's really, they said, "Yeah, we can stop the cords." No, we're on a boat, knucklehead.
My question is about underwater lakes. How does the water differentiate between ocean water and then ocean lake water?
Yeah, well, it's got all sorts of gases inside, like methane especially, and hydrogen sulfide. It's super salty, and we only find those things where there are huge beds of salt, and someone that studies them could say he's crazy, that's not what it is. But the Mediterranean has huge layers of salt because it evaporated before, and we find them in the Med. And in the Gulf of Mexico, we find them, and there's huge layers of salt there too. And they are super salty. So it just stays low because it's very dense water. Why it doesn't diffuse? Why is the boundary so crisp? Why do you see, I have no idea. Very odd. I'm sure someone somewhere has been working on it to figure out what makes it so crisp like that. Yeah.
I was wondering, how much, if any, have you used your skills and technology to collaborate with, like, film crews, documentaries, and such?
A lot, because now, you know, science has a way of getting funded through the government National Science Foundation. It's not easy to do that, because you're asking for several millions of dollars, and you almost have to predict what you're going to see. But often we turn to the documentary world to throw in a few $1 million. And then they put a crew on board, and it's always trouble because you always have to say, hey, this is a scientific expedition, we're not here to make a movie or a film. I will tell you, when the weather gets rough, very often the crew disappears, so they're gone. And after the Titanic expedition where we had the hurricane, they said, you know, Dave, we never got that part where you and the captain were discussing. I said, no, I know. And they said, well, we want to recreate that. I said, and I said, where, how? And they said, in your office. I said, no. No. One, I'm not an actor. And several times they would say to me, oh, can you roll up the chart? Sure. No, not like that. We roll it up a little bit this way and say, we need to get out of here quick. I said, okay, we need to get out of here quick. Can you say more emphasis? I said, no, stop. So yes, we almost every expedition that's not science, and a lot of the science ones bring a documentary crew with them. When it works well, it's fantastic. It really is. And when it works poorly, when your relationship is not great, it's horrifying. Yeah.
I wonder, like, what's your opinion on the scientist that does simulations and math models? If you are going to choose again, like, are you going to be a field scientist or
Yep, I marvel at that. I still am frightfully horrible with mathematics. I think I've had 5 years of introduction to calculus, which makes me very specialized. But in the case of Air France, for example, understanding the movement of water, especially the deep water, that has to be done through modeling for the most part. Air France is an expedition where we knew that a plane had crashed in the middle of the Atlantic, and that 8 days later we were picking up pieces of that plane, and so we had to figure out with current models where did they come from. And basically it worked fine. But in the case of the missing Malaysian airplane, it's been years now, and just now we're starting to pick up pieces on the African. It crashed somewhere near Australia, but we're just now getting pieces near Africa floating up onto the beaches. So there's some thought that we could backtrack using models, but you know, it's unlikely. The ocean's too complicated. You saw the Gulf Stream with all the swirls, and so how do you model your way through that? So it's difficult, but very powerful. Very, very powerful technique. Ideally, you use the sampling, especially with climate, to ground truth the model. And so you have to collect samples, but then you make your model and see if their prediction is correct. On the East Coast, our weather patterns, the weather predictions are horrifying because we don't understand the ocean effect. And for a storm to be 50 miles that way or 50 miles that way makes a big difference along the coastline and ruin my hammock, crush my hammock. I would have brought it in if they said exactly when, you know, the storm was supposed to happen overnight. I woke up in the morning, no storm, and I said, well, I'm going to leave everything where it is, and crunch, yeah.
What are some different parts or aspects of the ocean that you don't know that that you're excited to explore or learn about?
Yeah, so I'm retired theoretically. I'm actually busier than ever. I failed miserably at retiring. The thing that fascinates me scientifically, well, there's the animal behavior. There's a language that whales and dolphins speak. That's awfully interesting because we're finding out more and more about that. That dolphins, for instance, in their pods will be, every time they make a noise, they begin by telling you who it is that's making that. So they have these signature whistles in the beginning, and then they do whatever they do. The octopus camouflage and how bright they are. The deep sea, the vent sites, we think we're looking at biogenesis, so that at those places in the very deep sea where we have these very strange animals, there's also some very primitive, there's bacteria, there's archaea, all these primitive things. And for a while we said, how did they get down there? And now we're saying, wow, they're coming from there. So I think that's another very important one too. And the climate thing's interesting. And like I said, with the plate tectonics, you can see how the continents fit together. And I'm sure once we get enough information that climate, and actually we kind of have it, the big pieces do fit together as easily. I like that, the big puzzle pieces. But if I had to pick one, I'd go at probably biogenesis, what's really going on down there.
I've seen videos and it's like Jacques Cousteau building those underwater stations where you can then launch research vessels and kind of stay underwater for a long time. It's almost like a moon base but underwater. I guess what's your opinion of those? And then I have a follow-up question that is somewhat related, but I'd like to hear.
Normally that slide, I had a slide after the capsules of the space station versus those underwater stations, long-term habitation. I think they're great. You know, I don't think we'll ever get to that in the very deep sea because of the technology involved, the pressure. Well, I shouldn't say that. That's what I just said. Everything's possible. Anything's possible. But I think having a human presence there Because we really, in the submarine, we spend 4 or 5 hours on the bottom, that's it. You look at one spot. A submarine goes half a mile an hour, so you don't see much at all. So having that long-term presence is important. But what was the second?
It's also related because it's like human involvement in the sea. Like we drop shipwrecks every once in a while, and like New York throws their decommissioned trolleys in an effort to like do habitat reconstruction. I guess it's a similar question, like to what extent do you think humanity should intertwine with biodiversity and that sort of thing?
A controversial thing I always say is it's silly to ignore 70-something% of the planet and think that it's so fragile that we can't touch it. There's a lot of things that we put in the ocean that we shouldn't, but there's also things we could put in the ocean that we don't. And so, you know, the reef things are okay. They seem to be popular with the scientists. You know? And the thing is, even with Titanic, you know within a few minutes of how long that's been on the ocean, so you can study population of it, everything like that, where you normally don't have that luxury. So yeah, generally I think it's great. Was there a part B to that? I forget. Yeah. You know, well, one thing we try to do though is engineer things, and we always make a mess every time we tamper with the ocean, thinking that we're going to fix something by getting involved. It's always usually ends up in a disaster. Not as big. NASA has a program right now that if an asteroid were to head toward Earth, or if the Earth's orbit was drawing it more and more toward the sun, that we would go out into space and move some asteroids around so it would pull the Earth away. I don't think so. That sounds like having asteroid bits raining down on us.
Hello, I was wondering what you might study to become involved in this sort of research. You've mentioned, of course, engineering and marine biology and oceanography, but are there any other disciplines that one could look into?
Yeah, well, many schools now have oceanography as have them as courses and the like, or departments of oceanography, and certainly in grad school, there's plenty of grad schools. But the most important thing, I think, is your own curiosity and passion. What we look for usually in an expedition is someone with passion and someone that brings something to the table too. You know, it's good to, and it doesn't have to be ocean stuff. It can be anything. You know, it can be mathematics or chemistry or electrical engineer. You know, any of that stuff. And believe me, there's plenty that needs to be done in the ocean in terms of jobs, and both from the environmental side about keeping the oceans, keeping our relationship better, making our relationship better, and from the scientific side. Yes, money is tight right now, but I see that opening up. You know, one of the things we have to face right now is that to make our cell phones work, and if we want electric cars, you need rare earth elements. And there's a couple of places on Earth where you can get rare earth elements, but there's an awful lot on the bottom of the ocean. And so deep sea mining is coming up more and more about should we do that. Also, there's gold, silver, platinum at the bottom of the ocean. Again, in those mountains, probably much more than we have on land up here. So we're at a funny time where we're thinking about doing that because, again, if you want the electric lithium batteries and whatnot to drive electric cars, there's no free lunches. You've got to get them from someplace. So anything that you can bring to the table, including passion, works. Yeah.
Well, that unfortunately concludes the time we have. Dr. Bell, do you have a final comment for us?
And a lot of you know this, is the importance of passion and also curiosity. Keep curiosity alive, because I think the system by and large tries to knock off all the rough edges when you're younger, and I think that's always a problem. You know, we come all the way through the system of education. At the end, companies are saying, well, we want people that can think independently and work in a team, and so they end up retraining people. So we're doing a lot of things right, but maybe a lot of things wrong. But, you know, if you have a learning disability, don't give up. Find ways to cope and focus and have a goal at the end of it. And otherwise, you know, now's a great time. Looking back, I was told when I was a grad student, these will be the best times of your life. And I thought, haha, yeah, right. You know, I had all this stuff to do, comprehensive exams, thesis to write. And looking back on it, what a great luxury to be in a university or college and learn. You know, it turns out to be a pretty important thing. So I'll leave you with that. Yep.
And thanking Dr. Gallo.
Thank you. Thanks very much.